All right, how's everybody doing today? We're going to take a look at performing operations with complex numbers. Now, when you do that, we're going to take a look at four different things. The four things we're going to take a look at today. First, what is a complex number? I'm sure you're wondering. I was too, and we'll talk about that in a little bit. Second thing, really quickly, we'll go through adding and subtracting complex numbers. Third thing, multiplying in complex numbers. And lastly, dividing complex numbers. But first, a lesson in history. What is a complex number? Well, I had no idea, so I'm looking stuff up on Wikipedia because I'm like, all right, where did this come from? What was going on? And this is so cool. In the very first century, this guy by the name of Heron, he was working with trying to do some things with pyramids. And he had this problem where he tried to figure out the square root of a negative. And he's like, I don't know how to do that. So he just said, well, I'll just make it positive. And that was how he kind of dealt with that. Now, fast forward 1,500 years into the 1600s, and then there were these two Italian guys, Tartaglia and Cardoma, and they were starting to formalize the study of negative roots when solving cubic and quartic polynomials. They didn't really know how to handle it either, so they described it as fictitious. Now, fast forward to 1637, René Descartes, he coins the phrase imaginary number. And from there, things started to get a little bit more formalized when dealing with roots of negative integers. Now, go on almost 100 years later now, and now in 1730, this other famous mathematician, de Moivre, he ends up taking a look at imaginary numbers and trig functions, and he started playing around with that, and he comes up with his very own theorem that kind of related some things. So he ends up coming up with some cool things in 1730, which is kind of wild because George Washington, he was born in 1732. So that gives you an idea of like where this was historically as it relates to the United States. Not that we're looking at history, but when you take a look at this was going on around that same period of time. That's a long time ago. Then 1748, Euler, he came up with this way to reduce trig identities to make them simpler identities, and he came up with his very own theorem. Of course, it gets named after him. Euler's theory of complex analysis. Now today we can use complex numbers for engineering stuff, quantum physics, chaos theory, electromagnetism, signal analysis, number theory. There's all sorts of things you can use complex numbers for. What we're going to focus on here is going to be number theory. So let's kind of take a look at what is a complex number. Real quickly, it's just in this form, a plus bi. There's a real part, which is the a, and then there's the imaginary part, which is the bi. Now you could also write that. It could be written like this, a minus bi. So if you had a number that was complex, say you had 4 plus 2i, the real part is 4, and the imaginary part is 2i. So you had 4 minus 2i. Then again, your real part would be 4, but this time your imaginary part would be negative 2i. And sometimes what you'll do in some courses is you'll plot these in an xy coordinate plane, where normally we would have the x's go here and the y's go in the vertical axis, but instead that's where I goes, the imaginary piece. So you would treat this, if you wanted to plot 4 plus 2i, you just go 1, 2, 3, 4 that way, and then 1, 2. So that's where 4 plus 2i would be located. And then if you wanted 4 minus 2i, you would go down 2 on the vertical axis to negative 2. So that's where 4 minus 2i would be located right there. So that's just a couple of things that some courses will have you do. But here we're not talking about plotting them, we're just talking about adding, subtracting, multiplying, and dividing them. So let's take a look at adding and subtracting the complex numbers. Now for adding and subtracting complex numbers, this is just so pretty straightforward. You guys will pick this up right away. Now sometimes in some textbooks they'll just write it horizontally like this. You'll see 7 plus 5i plus 1 minus 4i. And that's all you're going to have to do when you see it horizontally is combine the real number parts. So 7 plus 1 ends up giving you 8. And then when you combine the imaginary number parts, 5i plus negative 4i, you end up with plus I. And that's it. That's all there is to it. Sometimes it might be easier for you to see that if you write it horizontally, or instead of writing it horizontally, you write it vertically. So if you have it written like this, it's a little bit easier for some people to combine. 7 plus 1 is easy to see, that's 8. And then 5i minus 4i, that's easy to see. That just combines to give you I. So either way, you end up with 8 plus I when you add them. Pretty straightforward stuff. Now, subtracting them is going to be a little bit different just because you have to pay attention to your signs. So if you have 7 plus 5i for your first one, and then minus 1 minus 4i, you have to be really, really careful of your signs, because 7 minus 1, that's pretty easy to do, that's 6. But then 5i minus negative 4i, that is going to give you plus 9i. Now, for some people, again, it might be a little bit easier to see if you write it vertically. It's pretty straightforward and easy to do, but what helps a lot of people sometimes is to remember to switch the sign of everything. So you'd still have the first set of terms, 7 plus 5i, that would stay the same, but then negative 1, and then that would go to plus 4i for the second term. And then you combine it like you would when you were adding. So 7 minus 1, you get 6, and then 5i and 4i, it's easy to see that combines to give you 9i. So either way you do it, it just kind of depends on you. And at this level of your math life, you should be able to combine like terms pretty straightforward. That's all there is to that. Nothing hard or difficult about that other than the usual keep an eye on your signs. And that's it for adding and subtracting complex numbers. Now when you multiply complex numbers, one of the things you're going to have to remember is that I squared has a value of negative 1, because that's going to be something that's going to play into this here. So first we'll go ahead and just set them up. So if we multiply that, now a lot of times people refer this, all right, use FOIL or the double distributive property. So 7 times 1, so if I multiply those two, I get 7. And then 7 times minus 4i, I get negative 28i. And then 5 times 1, or 5i times 1, I get plus 5i. And then last, 5i times 4i, I get negative 20i squared. But remember, I squared, that's right, that's negative 1. So when I'm going to clean this up here a little bit. So I'm going to have 7, and then minus 28 and plus 5i, that's going to give me minus 23i. Then I'm going to have minus 20 times that negative 1, because I squared is negative 1. Then 7 minus 23i plus 20. Then I'm going to combine my 20 with the 7, my integers. So that's going to give me a grand total of 27 minus 23i. I'm going to show you how to verify this on your graphing calculator. Now, depending on who your teacher is, they might want you to show your work and do all of that out the way that we just did that. Now, your graphing calculator will also do that for you, but you're going to have to know how that works. So one of the first things you want to do is hit the mode button. Now, the mode, if you go all the way down to where it says a plus bi, you're going to want to change that so that it is in a plus bi, or complex number mode. So you'll go down there and make sure that's turned on. Afterwards, quit and go home, so hit second and then mode. Then what you have to do very carefully is type everything in correctly. So you have 7 plus 5. Now the I is going to be right above the dot. So you're going to have to hit second and then the dot to get to that piece. So we've got that first quantity. Now for the second quantity, 1 minus 4i, we're going to have 1 minus 4, then second, and then our dot again, 4i. So when we do that, bam. Did we do it correctly? Yes, we did. So we didn't make any careless mistakes. Now let's just kind of take a side note here and pay attention to this here. What if you were multiplying two negative numbers together that were underneath a radical? Now a lot of times what people will do incorrectly is they'll say, oh, negative 7 times negative 2, well that would just be positive 14, so I'd end up with square root of 14. That is not correct. Alright, so don't make that mistake. What you need to do first is take the I out. So you're going to have I square root of 7 times I square root of 2. Now, when you do that, then you can multiply what's underneath the radical together. So 7 times 2, that gives you 14. So that's going to be underneath the radical. Then I times I, well that's I squared. But I squared is really the same thing as negative 1, so you'll get negative the square root of 14. So that's going to be some decimal. I know square root of 9 gives me 3, the square root of 16 is 4, so the negative square root of 14, that'd be somewhere between negative 3 and negative 4. So, and I could verify that if I look at my graphing calculator. So if I just type those two pieces in, check out what it does here. Now it gives us that as an answer. Negative 3.7. So if I were to type in the negative square root of 14, that's what we get. But here's what I'm curious about. Like, what if, before I took out the I, if I just typed it in that way? So if I did I times the square root of 7 times, and then another I, and then the square root of 2, like, does it give us the same answer? I don't know. We're about to find out. Holy cow, it does. That's pretty cool. So no matter which way I were to type that in my graphing calculator, I would end up getting the same result. What you've got to be careful of, though, is that you don't make the mistake that was there in the first part, where people will think, oh, I can multiply the negative 7 with the negative 2 because they're both underneath the radical. That property does not apply for imaginary numbers, complex numbers. It only applies for real numbers, which means the number underneath the square root would have to be a positive value. So just wanted to show you that real quick because I know that could be something that some of you might see somewhere in your dealings with this. Now let's take a look at dividing complex numbers. But before we get into that, what I want to talk about real quickly is this idea of conjugate. Now, before you'd learn about, you should have seen stuff like this in your algebra coursework. So if you were to see problems like this, you should be able to look at these and do these pretty quickly in your head. X plus 3, its conjugate is x minus 3. So when you multiply those two together, you just get x squared minus 9. X plus 4 times x minus 4, those two quantities, you get x squared minus 16, and you get the pattern after that. So that's the idea of a conjugate. And what we're going to do here is kind of play with that idea a little bit when we take a look at dividing complex numbers, because that idea of that pair, that conjugate, is going to play into this piece. Now when you divide complex numbers, what you're going to want to do is take one of the numbers, and it's always going to be in the denominator of a fraction, but more on that later. And you're going to need to multiply the numerator and denominator by the conjugate. So first, let's just go ahead and do this. 7 plus 5, its conjugate is going to be 7 minus 5i. That was easy. What's conjugate of 1 minus 4i? Well, that would just be 1 plus 4i. Think you got it now? Go ahead and do the next two. Hit pause, come back, and see if you correctly give those conjugates. All right, how did you do with that? Hopefully you did okay. Now, before we get into the next piece, in the next column, when we take a look at the product, there's going to be a pattern that I want you to kind of pay attention to here a little bit. Just like before, so let me go back to the previous page, how x plus 3 times x minus 3, that would give us x squared minus 9. There was no middle term. Watch what happens here when we do the same kind of idea here with the product for complex conjugates. So if I were to take 7 plus 5i times 7 minus 9i, and I'm just going to demonstrate this really quickly on the calculator here. Check this out. 7 plus 5i times 7 minus 5i, I just end up with a number? Seriously? Like, what's up with that? So those two products, I end up with just plain old 74. Well, how did that happen? So let's do this out the long way. 7 plus 5i times 7 minus 5i. All right, so if I were to FOIL that out or double distribute, 7 times 7, I get 49. 7 times minus 5i, I get negative 35i. And then when I do plus 5i times 7, I get plus 35i. Okay, so that's going to be kind of like the distributive property before, or when you multiply conjugates, those middle terms will cancel out. But then I have the last term, plus 5i times minus 5i, so that'll give me negative 25i squared. Well, wait, what's the value of I squared? Ooh, that's right, it's negative 1. So what I'm going to have left is going to be 49 minus 25 times negative 1. And I'm just doing this out the long way, and you'll get the idea here real quickly. What's 49? And then that's going to go to plus 25. 49 plus 25, well, that gives me 74. Holy cow, check that out. That's pretty wild. Here's what I want you to kind of pay attention to. What's 7 squared? Well, that's 49. What's 5 squared? Well, that's 25. If I add up 49 and 25, what do I get? Holy cow, that's 74. Pretty cool. So check this one out. On the next one, what's 1 squared? Well, that's 1. What's negative 4i times 4i? Those two, when you multiply those together, just look at the integer. What's 4 squared or negative 4 squared? You get 16. So if I add those up, 1 plus 16, I get 17. So the product of 1 minus 4i and 1 plus 4i, that would be 17. Let's check that out and verify that on our graphing calculator. Ooh, check that out. Holy cow, it is. That is wild. So now let's take a look at the next one. 6 minus 5i times 6 plus 5i. By now I think you guys might have this patterned out. 6 squared, well that's 36. And 5 squared, that's 25. If I were to add those together, 36 plus 25, I get 61. Check it on a calculator. Verify. Make sure that your answer is correct, because the last thing you want to do is make a careless mistake. And actually, go ahead and do the next one. 3 plus 2i times 3 minus 2i. Multiply those two together and come up with their product. Then double check using your graphing calculator to make sure that you are correct. So hopefully you did okay. You got 61 for the product of 6 minus 5i times 6 plus 5i, and you got 13 for the product of the last one. Pretty straightforward stuff. Now we're going to use that when we go to divide complex numbers. So check this out. All right. Now for this next one, when we're dividing complex numbers, what you're going to need to do is look at the denominator. In the denominator, we've got 1 minus 4i. So what we're going to do is multiply the numerator and the denominator by whatever the conjugate of the denominator is. So you guys know how to do that by now. The denominator of 1 minus 4i is 1 plus 4i. So that's going to go there. Now, when you go ahead and multiply that, just take your time. We already kind of know what the denominator is going to be, but let's go ahead and work with the numerator first. 7 times 1 is just going to give us 7. And then 7 times 4i, we're going to get 28i. 5i times 1 will get 5i. And then 5i times 4i will get plus 20i squared. And then in the denominator, we're going to end up with 1 times 1 is just 1, and then 4 times 4 is 16. So we're going to end up with that in the denominator. Now, in the numerator, we're going to go ahead and kind of clean some things up here. 7 is just going to stay at 7 for right now. 28i plus 5i, that's going to give us plus 33i. And then our other piece, 20 times I squared, since I squared is negative 1, 20 times negative 1, that's going to give me negative 20. So that last term is going to be negative 20. All that is going to be over 17. Now when I clean up those two in the numerator, my two terms, my like terms, 7 minus 20, I get negative 13 plus 33i. All of that is over 17. So that's what my final answer is going to look like. Now, well, let's go ahead and put this in a graphing calculator. Now, you used to be able to do this one way. And watch what's going to happen here. So you're going to go ahead, type everything in, and then watch what happens when you hit enter. This is going to be weird. We're going to get some funky old decimal. Now, I don't want to deal with that decimal. I really just don't. So in the old calculator, one of the older operating systems, here's what you used to be able to do, because you have decimals. So it's like, all right, just use MathFrac. A lot of teachers will talk about that. So you would just hit the math button and then just choose fraction, changes your answer to a fraction, and then yuck, we get this error message that says data type. In older operating systems of the TI-84, you used to be able to just do MathFrac, and that would give you the answer. With complex numbers, that doesn't work. So here's how we get around that. So you're going to go back to the problem, and what we're going to do is just type in each piece separately. We're just going to multiply the numerator, get our answer, multiply our denominator, and get our answer, and see if that matches up. So here's how you would put everything in. So you're going to take your numerator, 7 plus 5i, and multiply that by the quantity 1 plus 4i, and notice we get negative 13 plus 33i. That matches with what we came up with in the end. And so does our denominator when we have 1 minus 4i times 1 plus 4i. That quantity, those two quantities, when we multiply them together, that gives us 17. So that's the way around it. If you have a newer operating system, it won't let you just do MathFrac. It'll give it to you in that form. So that's how you get around that. Pretty straightforward, but again, it is a lot of button pushing, but I know you guys can handle it. Most of your teachers, though, will probably want you to do it the long way. They may or may not let you use your graphing calculator to check it. But when you guys are doing homework or practice problems, definitely use that tool to help you verify things. But like anything, don't let that tool become your crutch. All right, so we're going to take a look at one other example here, because sometimes, like in our case here, our denominator had both a real and an imaginary part. On the next one, that's not going to be the case. So I just want to do one more example where that's not going to be the case for you guys. In the denominator, we don't have a real and an imaginary part. So we're just going to deal with the imaginary piece, that 5i. Well, what's its conjugate? This is almost the same thing as 0 plus 5i. So its conjugate would be 0 minus 5i. So we're going to multiply the numerator and the denominator by negative 5i. Now again, just take your time when you distribute. Negative 5i times 1, we get negative 5i. And then plus 20i squared. All that's going to be over 5 times 5, that's going to give me 25. Now I've got to clean the numerator up a little bit. Negative 5i, and then 20i squared. Do you know what that's going to give you? You should by now. That'll just give you minus 20. All that's going to be over 25. But wait, we're not done because we have to write that in standard form. So standard form is going to give me negative 20 minus 5i, all that over 25. But wait, we're not done yet. We still have to reduce because notice 5 will go into each one of these terms. So 5 goes into negative 20, negative 4 times. 5 goes into negative 5i, just 1i tie. So that's going to be negative I. And then 5 goes into 25, 5 times. So that's what I'm going to get when I'm all done dividing these two complex numbers. Now again, let's verify this on the graphing calculator. So when I go ahead and do that and I check that, notice I have negative 20 minus 5i in the numerator and then 25 for my denominator, which is what I had. The only thing I have to do next is just make sure that I took my time and I did my reducing properly. So that's it for dividing complex numbers. Hopefully you found this informative and you got a handle on how to use your graphing calculator to help you work with adding, subtracting, multiplying, and dividing complex numbers. The adding and subtracting shouldn't need it for that, but definitely on the multiplying or dividing, that you definitely want to use your graphing calculator as a tool to help you verify your solutions. Thanks for watching. Have a great day. Peace.